On page 6, you will find an optional activity. There you are presented with two case studies and asked to make recommendations concerning run times. I would encourage you right now to take the time to read over the scenarios and come up with some answers. And when you're ready, come back to the video here so we can review together. Case number 1 is a large migration. A customer is preparing a very large data migration to a new field service platform on the Salesforce environment. Millions of records must be migrated from the legacy platform with complex transformations and logic. The records will be divided into batches of 100,000 records. Performance testing shows that a batch will run in about 40 minutes, and you are called in to make recommendations for the migration runtime architecture. The customer is currently using local atoms on dedicated servers. Should the client consider installing a molecule? Yes, there would definitely be an advantage to using a molecule to divide and conquer the work and allow for load balancing. You could use this with the flow control shape to limit the number of documents per thread and fork, thereby making your processes run more quickly. The second question asks, the customer fears that there may be atom resource limitations as some out-of-memory test runs have occurred. How would you address these in the runtime architecture? Well, this is a nice feature of being able to fork executions. You can enable forked executions in the molecule, and that way each process executes separately from each other and would not crash other JVMs. Question number 3. The customer has read about threaded execution in the reference guide and believes that a flow control step with 10 concurrent threads will speed throughput. Do you support this approach? This kind of depends on how it is set up. 10 concurrent threads on a local atom would likely not gain you much since they are all using the same heap space. So if there is a lot of throughput already, simply adding more threads will not help. But using threads on a molecule would be a better approach because then each node has its own resources to use as it executes its threads. The last question asks, in summary, what are your runtime configuration recommendations based on the content provided in this module? So I would suggest the customer uses a molecule with forked execution enabled and flow control. The molecule allows for load balancing, and the forked execution isolates each execution in its own JVM and can make greater use of system resources. The flow control allows you to set the batch size and set the scope to process rather than thread to instantiate a new JVM for each batch. Case number 2 is an internal web service. The customer is implementing an internal web service using service-oriented architecture guidelines. The use case is to provide consistent, timely inventory level information for 20,000 SKUs across 3 warehouses. The web service will be implemented in Boomi Atomsphere using the web service component and will pull data selectively from one of the 3 warehouses based on several factors including SKU and geocoding. The Boomi process servicing the web service will implement the logic needed to query the correct warehouse and return the current stock level. The inventory web service is expected to handle several thousand queries a minute at peak. You are called in to make recommendations for the inventory runtime architecture. So there's 3 questions here. Question number 1 says the customer is currently using local atoms on dedicated servers. Should the client consider installing a molecule or a private atom cloud? Well, a private atom cloud is probably a good solution for only very, very large companies, and molecules by themselves are in fact extremely powerful. So yes, they should use a molecule to allow for load balancing and greater use of their available resources. Question number 2 asks, the customer is concerned that latency in the Boomi platform will reduce performance. How could latency be minimized in the runtime architecture? Are there different approaches? We made the strong recommendation as we were going through the information that real-time processes should always have the low latency option enabled. They could also check to make sure to optimize the processes by limiting connector calls, avoiding shapes that write to disk because that increases the processing time, and avoiding persisted process properties since they are also written to disk. In summary, what are your runtime configuration recommendations based on the content provided in this module? The suggestion here would be that the customer uses a molecule with the low latency option turned on. Because this is a web service being served, I would also add an external load balancer since the molecule is not good at handling a real-time load balancing.